and 3. Today is Tuesday, September the 1st, and what we have here, it's basically a bipolar rectifier, similar to connection diagram E2380 for TIMET Henderson. The only difference is that we're running, instead of 208, we're running 480 from the wall, 3-phase. And we're going to show basically the setup, we're going to show the sequence, we're going to take a look at the feedback, and we're going to monitor a couple of signals. The setup, we have here the 12 SCRs, 6 dual SCRs. Here we have our bipolar board. Here we have our regulator board. All these connections, all this interface, it's here. Here we have the input. Here we have the output. We have our voltage and current feedback, and that comes over here to our load, where we're going to monitor the output voltage and current, and we can even take a look at our signal on the scope. We're going to be monitoring the AC input, or voltage and current feedbacks. This is our current command, and here we have our output. Now I'm going to ask Tony to apply the 120 to the system, basically bringing in 120 here between positions 15 and 17 as shown in 2380. So what we have here is we have the green LED, we have the phase loss LED, and we have the inhibit LED. We're not transitioning, so the transition LED is off. What we have here, what we should have at least, it's the green LED on the regulator board. Notice that we have all our potentiometers at 100%, and we have put this together in such a way that the voltage command is pulled up at 12 volts. That is JU3 is installed, but JU4 is out because we're bringing in the external current command. By the way, we're doing this at 480. If we had 208 coming in, the two resistors for the correct feedback will be 511K as shown here, and 8.45K to get the 4 volts. Now, once we have this 24 going to the board through this 120 to 24 transformer, I'm going to apply the 480. Can you inhibit, Tony? And what we have here is we've cleared the phase loss. Here we pretty much are okay. We've cleared the phase loss, and now we're going to enable. In this particular case, we will take the 120 at least through here, and we will soft enable. So let's go ahead and enable. When we're enabled, the only LED that's on, it's the green LED. And let's go ahead and, we don't have an output. We have 480, 474 coming in. We don't have the output, it's only 6 volts. Where we are right now, and there's basically no current. So I'm going to ask Tony to start increasing the current command. We see the delay angle closing in. Alright. Yeah, we can come back to that, Tony. You want to go ahead and start increasing the command. And then what we have here is we are at 500, 600. I'm going to turn the fan to cool up my pen. Are we down there, Tony?
Yeah, we're full on.
So we're at 610. Here I can see my output. I'm going to show it here at there's my output at 5 milliseconds per division. I have the 6 in 16.6 milliamps. I should have my 6 rectifier outputs with 610. My current, that's my current, and that will depend on the customer load. And basically what we have here, it's still the 480, just sagging a bit. The current feedback through the shunt, it's 50 millivolts, and we've set it up like that with our own resistor values or feedback, the voltage feedback measured at J1 between positions 1 and 4 on the regulator, it's 4 volts. And the current feedback at J1 between positions 3 and 4 is the 50 millivolts. Again, we're applying our current command. And right now, the way the board is set, with approximately 7.3 volts, we get our maximum output. You want to go ahead and comment in, Tony? And if we wanted to get 10 or 12 volts, it will be a matter of changing resistors on the current command path of the board.
You do want a transition?
Not yet. Let's just go ahead and start coming down. So as Tony is changing that, we can see here that the output is being reduced. So let's go ahead and bring it in, Tony, so that the output is probably say 400 volts DC. Approximately, you don't have to do 80, 40, 480. Okay, a little bit more. That's good. 434. So let's go ahead and get a polarity transition, and we're going to take a look here at the output, and we can see now that it's transitioned into the opposite, and now we have minus 44. Can you do it again, Tony?
Yeah.
I went to minus 434, and there's our output. The last thing that we want to show here is that if we go to TP7, which is seek high on the small board, that's the seek high. You get a maximum output. Yeah, go to the maximum output, Tony. This is the value that I was asking you to check. That will be between 5.8 and 6 volts. At 5.9, we have the maximum DC output. And the last thing that we requested you to do is to remove this connection, and I want to show what J3 position 6 with respect to common is, or what the 12 volts is on the board. We have 12.02 volts, and that's because the 12 volts from here and the 12 volts from here are disconnected. So the 12 volts on the regulator board, it's healthy. This is the end of this video.